In this lab, we're going to talk about writing in Sage, and in particular how to write specialized mathematical symbols in Sage. For that, Sage uses a program called LaTeX, and it's another free program designed for typesetting technical documents, not just math, but very common in math. Any type of field that requires very specialized symbols that maybe Microsoft Word isn't the best choice for. We'll talk a lot more about LaTeX in Calculus 2, but for now we'll just use some LaTeX commands within Sage so that we can produce text that has math in it. First off, just to get text in Sage, you could just type text, of course, in an empty cell. But if you run that cell, then Sage will think you're trying to run some sort of commands. It won't recognize it as text. So if you want to tell it that it's text, you need to kind of mark that at the beginning. There's this little decorator here, right, this %MD, and if you start a cell with %MD, then Sage will interpret that as text. So we can do that right here. I left a blank cell, just put %MD and hit enter, and now type some text. And if you run this, it now produces this text output. And if you want to, the input's still here. If you want to hide that, click on the little arrow and it will hide the input, and now you have the text output here. Now the MD stands for Markdown, an abbreviation for Markdown. Markdown is a program that was designed to make it easier to write web pages, so it's a shortcut for HTML, and Sage uses HTML to produce its output. So there's really HTML in the background. If you know HTML, you can type HTML code right into this text cell here with %MD. You can type whatever HTML you want, and it should be rendered correctly here in the output. I'll talk about some of the basic features of Markdown. I gave you a link to the Markdown webpage above if you want to look more in depth. One thing Markdown does is allow you to do headings in a simple way. So to do a heading, you just put a pound sign or 2 or 3 or 4 in front of it. That determines the level of the heading. So pound sign and then a space, and then whatever you want in that heading results in this level of heading. So it's kind of bigger. And if you have more pound signs, then like this one, 4 pound signs gives you a level 4 heading. You can see this is smaller. So the more pound signs you put, the smaller the heading gets. Don't forget this space after these pound signs. That's not optional. If you leave out the space, then Sage will think you're trying to write a hashtag and won't do the heading. If you want to emphasize something in your text, you can do bold or italics very simply. For italics, you put a asterisk before and after the thing you want in italics, and it italicizes it. If you want bold, you put 2 asterisks before and after, and you get bold. Of course, there's HTML codes that do those as well, but they require more characters to type. So this is kind of a quick and easy way to emphasize something just by adding some asterisks around it. Markdown also gives you a way to do lists, either bulleted lists or numbered lists. So for a bulleted list, you just type an asterisk and then a space, and if that's what you type in your input cell with %MD, when you run it, this is the output that gets produced. So these asterisks get changed to these bullets. To make a numbered list, you just put numbers and then a period and then a space, and that will produce a numbered list. Now here I have 1, 2, 3 in order. You don't actually have to have them in order, so if you decide to add an item, all you need is a number. In fact, I think all these numbers could be the same, and you would still get, Markdown would interpret that as a numbered list and would automatically create the numbers in order, whether you have them in order yourself or not. If you want to change text that's already there and the input has been hidden, you just have to click the arrow over here. So go to the line above and click the arrow. See how it's kind of pointed sideways? Click the arrow, now it's pointing down. It's revealing the input. So here is the input that produced that. So you can change it. Actually, I don't edit that one. Try to edit this one down here. So we'll click the little arrow, and now we will try to change this text. And we'll hit run, and now it's been updated. And again, if you want to hide the input, you can hide the input again. Now you gotta be careful with deleting. I think you've probably seen by this time that some of you have accidentally deleted questions from the assignment and such. It's really easy to delete things accidentally. So if you want to delete an entire text cell, then you can just position your cursor in front of it and hit delete. So let's see, I think, is my cursor there? Oh, moved down. And if I hit delete, okay, there it's gone. And I'll hit, oops, I hit Control Z to bring it back, and it skipped down. If you have trouble positioning your cursor like right on this line, you might click the line and then you have an extra line there. Okay, well now your cursor is before it, you can hit delete. I hit delete once and it took out that line. I have to hit delete again for that text to actually go away. Notice that when you delete that, it takes away the output that's here as well as the input that's behind it. So you might not notice you're deleting that text input. If you want to delete just the output but keep the input, you can open it up, and now the input is here, and you can position your cursor after that and hit delete, and the output went away. Though, kind of a warning here, it also deleted the dividing line between this cell and the next one. As you can see, this is now suddenly merged with that. So that's kind of dangerous to do that. I can always put the dividing line back. That's hold down Control and hit semicolon, and that puts a dividing line. And now this input has been revealed. I can run this again. Actually, I don't think I need to. I think it's already there, so I can just hide this input, and this hasn't changed at all. So be careful deleting text. It's easy to delete too much. It's easy to delete things you didn't mean to. Here I added an extra line that I didn't want, and so maybe I'll take that away. Okay. So sometimes it's better to leave extra stuff you don't want rather than deleting it. So Control Z or the undo button up above will undo deletion if you accidentally delete too much. So that's some of the basics of just getting plain old text and doing that. Now if we want mathematical symbols, we need LaTeX to help us. So if you just type, like if this is a function right here, if we want to type that, this is how we would do it. This is the raw text. That's not what we want it to look like. We want it to look like this. We want this nice little superscript, and everything's kind of formatted nicely. This just looks kind of messy. Now there's of course HTML approach where you could at least get this superscript there, and you could notice this is in italics. But LaTeX does more than just superscripts and subscripts and italics. It's also the spacing. So notice that there's a little bit of space around the plus that it's added. Okay, we didn't have a space there. We could have manually added a space if we wanted to. But LaTeX is kind of taking care of that for us. Spaced it out to make it look nice, and that's what LaTeX is for. Now the way you get this to appear, nice looking math, instead of this computer looking math, is by putting dollar signs around it. So put a dollar sign before the f of x, put a dollar sign at the end. Those dollar signs tell Sage that we're using LaTeX. So instead of just producing the ugly text like this, it will produce this nice looking formula. Notice that the dollar signs don't appear in the output. If you go here and click on the arrow and see my input, this is the input that produces that nice thing. It has dollar signs there, but when we run this, the dollar signs don't show up. The dollar signs is just telling Sage to use LaTeX, so what shows up is the nice math thing. If you use a single set of dollar signs, then you'll get your math formula right here in line where it is. So it's part of this sentence, it's right there in line. If you want to have your math stuff set apart, you can use double dollar signs instead. And that puts it in its own line and centers it. and it also uses display style, which I'll talk about later. So if you really want it set apart, use double dollar signs. Now if you kind of research online about LaTeX, you'll find that this dollar sign and double dollar sign has kind of gone out of favor, and some people prefer another option for this, what's called math mode. So just be aware, you might see another alternative. There's a slash parenthesis or slash square bracket that people use, but I tend to use dollar signs. That's kind of what Sage is set up for. It's the old-fashioned way perhaps, but it will work here in Sage. So just some miscellaneous symbols, and this is by no means a complete list, kind of a hodgepodge. What I want you really to see from this list of symbols is that in LaTeX, commands are preceded by a backslash. So to get a specialized symbol, there is some command name for that specialized symbol, and it has a backslash in front of it. So for example, to get approximately equal to, that's this little squiggle. You type backslash approx. And so here's the code, dollar sign for LaTeX, and then backslash approx produces the little squiggly lines for approximately equal to. So in order to get these specialized symbols, you just have to know the command name, and then you put a backslash in front of it. So backslash PM produces a plus or minus symbol. Backslash pi produces the Greek letter pi. Backslash alpha produces the Greek letter alpha. If you want capital Greek letters, you just capitalize. Backslash pi with a capital P produces a capital pi. Backslash sigma with a capital S produces the sigma. Now, not every one of these will work, as I mentioned here. If our regular capital letter, that's or the Latin capital, is the same as the Greek capital, then it won't work. So for example, backslash capital alpha gives you an error because capital alpha looks the same as our regular capital A, so you just type capital A. But other than that, which there's a few letters like that, you can get all the Greek letters just by kind of typing out their names. Greater than or equal to are also specialized commands, so backslash GE for greater than or equal to, backslash LE for less than or equal to, produces these symbols. If you want just a simple less than or greater than, you just type it on the keyboard. So no special command for those. Okay, so I have a list of LaTeX symbols that might be useful to you. They're included in your assignment folder. That's just in a PDF. And of course, you can always just Google, if you forget how do you do approximately equal to, you just go Google LaTeX approximately equal to, and you'll find out this command for that. Now, if you want to do fractions and roots and powers and all those kind of things, you just need to know the LaTeX command for those. A lot of them are similar to Sage commands, but there are some important differences we'll need to point out. I don't expect you to memorize all this material and completely master it. I just want to point out some of the different ways and give you examples. So if you need to produce any of this, you just come back and kind of copy the examples I provided and adjust them as necessary. So for fractions, the command is backslash frac, and then there's two arguments that get fed to this fraction command. One is the numerator and one is the denominator. And in LaTeX, you enclose arguments not in parentheses like in Sage, but in curly brackets. So here's the general backslash frac command, dollar sign for LaTeX, backslash frac for fraction, curly bracket for the argument. The first thing you feed it is a numerator, and then end curly brackets. Then a new curly bracket, you put the denominator and the curly brackets. So for example, here's what you would type to get 3/7. Here is a more complicated one, rational function. So backslash frac, curly brackets around this quadratic for the top, curly brackets around the line on the bottom, and it produces this fraction. Now in a complicated one like this, where you got powers within the fraction, it might get a little hard to see at this size. So LaTeX tries to fit that whole fraction within this line, and you can see it kind of has bumped these lines apart a little bit to make room for the fraction, but still it's small. If you want full-size text in the fractions, you can add this little optional command, backslash display style. That doesn't require any curly brackets or anything. It's just whatever comes after display style will be put in display style, and you can see the difference. This is the same fraction with display style. This is the fraction without. Display style just makes the numerator and denominator both normal size. Now that does make more space between the lines. As you can see, there's less space between these lines than there is here. So you have to kind of balance that out, whether you care about spacing or the size of the fraction. If you use double dollar signs, then that display mode is automatic, so you do not have to use display style with double dollar signs. So it's set apart on its own, so by default it's kind of the full size in display mode. If you want to write a power, use the caret, just like in Sage. The slight difference here, though, in LaTeX, if you just type like x caret 2, you will get x squared. But if the exponent has more than one character in it, then you need curly brackets around it. So whether it's a minus and a 1, or two numbers, or this complicated quadratic, you need curly brackets around those things. So compare what happens if I do 3 caret minus 2 versus 3 caret curly brackets around minus 2. The first one gives me this. Notice that the 2 is not in the exponent, only the minus sign is in the exponent. And that's because I didn't put curly brackets. It only takes the very first character after the caret and it makes it a superscript. And if I want two things in the superscript, in this case a minus and a 2, I need curly brackets around it. To get this whole quadratic in the exponent, I just put 3 and then caret and then curly brackets around the whole quadratic. Whatever is in the curly brackets gets superscripted here. Okay, so really a power is with the caret is just a superscript. So if you just want to superscript something, that's the way to do it. You might just want to get in the habit of always using curly brackets after the caret rather than thinking about whether you need them or not. Most of the time you need them, so you might just get in the habit of always putting them. That doesn't hurt anything. Roots, the command is \squirt. It's the same command as in Sage. Of course, the difference is, like in LaTeX, all the time you need a backslash in front of the command, and instead of parentheses afterwards, you need curly brackets. So watch out with this one. You're in the habit of doing sqrt parentheses in Sage. Now in LaTeX, you gotta remember to put the backslash, and remember, don't put parentheses, put curly brackets. Of course, now that you're going to do this in LaTeX, then you're going to go to Sage and try to put curly brackets, and that's going to be a mistake. So try to keep them separate. Sage and LaTeX are very similar here, but very important differences. So, for example, $ for LaTeX, \squirt for square root, curly brackets, and then I have this quadratic in here. Notice that LaTeX automatically lengthens this square root bar so that it covers everything inside. That's the beauty of LaTeX. It makes everything fit inside there. If you want a root other than the square root, it's the same command, squirt, but then you use square brackets right after the squirt. Before you'd use curly brackets, which tells LaTeX what's inside the root, you put these square brackets right afterwards, and you can see it puts the 3 right here. That's the other way you tell something to a command. Commands that take input always need this curly bracket stuff. These square brackets are for options, really, to kind of, in this case, it's the option is change square root to cube root, or here I have bracket 8, it gives me the 8th root, and so on. So you'll see a few commands have optional arguments, and those are in square brackets, as opposed to the required arguments that are in the curly brackets. So that shows up a few times in LaTeX. And here's what happens if we add display style to this same thing. It makes it bigger, easier to read. If you want to do limits in LaTeX, you type \lim and it produces this limit. To get the subscript in LaTeX, use an underscore. Underscore is sort of the opposite of caret. Caret does superscript, underscore does subscript, and of course you want curly brackets after it, just like with the caret. Here I want x approaching 1. Backslash 2 produces this arrow. So this is backslash, x backslash 2 1, x approaching 1. Now normally we don't really like this subscript approach. We normally write the, like down here, x approaching 1 below the limit. If you want that, you just need to include display style. So this is the one without display style. This takes up less room. This one requires more room in display style. Put this underneath so it spaces the lines more. So depending on how you want it to look. Here's another example. This is the difference quotient. So display style to get the h approaching 0 underneath the limit. Backslash lim to get the limit part. Underscore for the what's underneath. H backslash to 0 to get h approaching 0. And then what I have in that limit is this fraction. So backslash frac, curly brackets around the numerator, curly brackets around the h for the denominator. If you want to limit at infinity, the command for the infinity symbol is backslash inft. Whoever programmed LaTeX was too lazy to type out the word infinity, so it's just inft. And so here's backslash inft right there in that limit to give me the infinity. If you want minus infinity, just stick a minus sign in front of the backslash inft, and it'll stick the minus sign there. If you want right or left hand limits, you just need a little plus or a minus in the superscript. So here's a right hand limit, there's a little plus in the superscript, there's a little minus superscript, and that's just a caret. Caret does any kind of superscript. So here I have 1 caret plus, here I have 1 caret minus, and that gives me the little superscripts for the right and left hand limits. If I want to do derivatives, okay, unlike Sage, Sage doesn't like you to call derivatives f prime, but it's fine in LaTeX. We're just typing text here. So it's a little hard to see that there's an apostrophe after my f. So this is $f, and then there's an apostrophe, and in this font it kind of is hard to read right there. But there's an apostrophe right there, and this is what it looks like when LaTeX processes it. So it changes this apostrophe, kind of a single quote that's rounded, it changes it to a prime. For second derivative, type double prime. Okay, there's 2 apostrophes there, and it gets double prime. Here's 3 apostrophes to get triple prime. Now you might be careful in Sage if you have auto brackets turned on, which is turned on by default. I actually have mine turned off. If you type a parenthesis and an open parenthesis and the closed parenthesis automatically appears, then auto brackets is turned on. And most of you, that's probably what it is. You can turn it off if you want to. You go up into the settings. I think it's the overall settings. I forget exactly which settings it's in. I just pushed the my name where it has a little gear symbol on it. Sorry, it's off the screen. This pulls up to the general account settings, and here is auto close brackets right here, and you can see mine is unchecked, and yours, most of you probably it's checked. You can uncheck it if you want, but if you like auto brackets turned on, then you can leave it on. The reason I bring it up now is the auto brackets also, if you type a quotation mark, it automatically inserts an end quote as well. And so when you're typing primes, it might think you're doing quotations, and it might automatically insert a second one. So you think you're getting f prime, but you'll end up getting f double prime. Just be aware of that and watch out. Once you run it, you'll see if you have extra primes or not. If you want to go higher than triple prime, maybe quadruple prime at the most. After that, it gets kind of ridiculous to have 5 or 6 or 10 primes. So we start using this notation. This is the 5th derivative. It's the order of the derivative in regular parentheses, and that's a superscript. So you just use the regular caret. All right, so here it is, f caret, curly brackets for what's going to be superscripted, and then parentheses around a 5. That produces this thing. Now if you prefer Leibniz notation, you just can type d over dx just like a regular fraction. So backslash frac, curly brackets d, and curly brackets dx produces this fraction d over dx. As far as LaTeX is concerned, that's just a regular fraction, and that's how you input it. If you want a higher order derivative in Leibniz notation, these are just superscripts. So here is caret 3 produces these superscripts. Of course, if you want the 10th derivative or higher, you're going to need curly brackets around the number after the caret to get it all in the superscript. Summation notation, we're not going to need this until calculus 2, but I put it here just for future reference, so I'm not going to go through it in detail. You can see that there's a command \sum which produces this summation, rather than using the, it's a capital sigma, but you don't really want to use capital sigma. The fact you're using the sum command, when you use display style, it will put these subscript and superscript below and on top instead of next to it. So that's kind of the advantage of the sum command. I'll leave this here for you to look at later if you need to do summation notation. Integrals, we'll also do more of this in Calc 2, but if you want to do an integral in Sage, in LaTeX, the command is \int, and that produces the integral symbol, and then whatever you want afterwards just will appear there. Now, if you want the dx, you can just type dx right afterwards. Usually, if you do that, there's no space there. I don't know if you've noticed yet, but when you put spaces in LaTeX, they're ignored. So even if I put a space between the f of x and the dx, LaTeX will remove that space. If you want a space, you have to manually tell LaTeX to put a space there. And there's various ways to do that. You can put \, and then hit the space bar, and that'll produce kind of a large space. What I like to do, which is kind of a subtle thing, \comma. \comma produces a little space, and so we get a little space between there. Just \space, I think, kind of produces a little too much space between there. Leaving out the \comma, they get kind of merged together. It's not that big a deal, but just, I don't know, a little technicality there for you. If you add display style, it will lengthen this thing and make the integral symbol bigger. If you have a definite integral, the lower limit of integration is a subscript and the upper limit is the superscript, so it's underscore for subscript and caret for superscript. Display style gives you this elongated integral symbol, and then they're put kind of up there, so that looks nice. Of course, if your limit of integration is more than one character, you need curly brackets as always. So underscore curly brackets -2 and caret curly brackets 18, because we have more than one character in those. And then here, if you use double $signs, it will set it apart automatically to use display style, center it. If you want to type text within LaTeX, there is a text command, just \text. That's also a way you could add space by just doing \text and then having a space there, like I have here, \text, curly brackets, and then space and space. These spaces between the f of x and the \, and between the curly bracket and g, LaTeX ignores those spaces. But within the text command, it includes the spaces, so we get that. Now, I don't know, sometimes you might want to have text within your LaTeX, but if you've noticed, the LaTeX stuff is usually a little bit bigger than the surrounding text. So here's the just regular text, not in LaTeX, just with the regular %MD. And here's the and was produced by LaTeX, and it's a little bit bigger, almost a little bit thicker, almost not quite bold, but I don't know, it looks different, kind of different font or something. So if you want and the same size as everything else, you could just do LaTeX, two different kind of LaTeX here. You can put curly brackets just around the F, and you can put not curly brackets, I'm sorry, $signs around the F, $signs around the G, and the and here is not within the $signs, and it's just regular text, and you could do that. But there might be occasions where you want text within your LaTeX code. You can also kind of cheat and let Sage produce LaTeX code for you. So if you have mathematical expression in Sage, you convert it to LaTeX. This is within Sage now, not within a %MD cell. We're not text, but within a regular input cell. If you type the Sage command LaTeX, parentheses, and whatever you put inside there, Sage will convert to LaTeX. So if you go to a regular input cell, okay, not a %MD cell, but just a regular cell, you type LaTeX 3/4 and hit run, it will produce \frac curly bracket 3 curly bracket 4. and then you can just copy that output into your text cell, put dollar signs around it, and it will work. If I run this in Sage, derivative cosine of 1 over x to the 5th, it will produce this output. If I then say LaTeX underscore, remember underscore is the last output, so if I do this immediately afterwards, it will convert this output to LaTeX. And what I will get is this big ugly mess. Now this LaTeX code is probably a little bit more complicated than what you would type yourself. There's a little backslash left here and a backslash right, which I haven't talked about. We'll mention that in Calc 2. So there may be a little bit extra stuff here. There's a backslash comma to put a little space between the 5 and the sign. It's usually fine what it produces. It might not be exactly what you would do, but it's fine. And by the way, if you put this derivative command inside the LaTeX command, the derivative will be calculated first. So you will get this thing. It won't convert derivative of cosine into the formula. It will into LaTeX formula. It will convert the answer into the LaTeX. If there's any symbols you need in the future that you're missing, you can always just search online. You type LaTeX and whatever it is you want to do, and you'll find all sorts of help online. There's a big community of LaTeX users online. But if you need help finding something, feel free to let me know. And like I said, you can always mimic my own text. If you want to know, well, how did I do this integral again, you can always just click on the little arrow and you can come down here and say, okay, here's his integral, and you can copy this and you can edit it like however you want. So you feel free to mimic my own code in these. Final remark, if you have lots of mathematical things together, you don't need dollar signs around each individual item. So in the past, I've seen students who see I have this whole equation, f of x equals this fraction, and then I simplified the fraction to this. And I've had students that put dollar signs around the f, and then they'll put dollar signs around the fraction, and then they'll put dollar signs around the answer. You can do that, though here the equal will not be processed by TeX, and so it won't look quite as good. You can just put $1 sign at the beginning and $1 sign at the end and all the math you want in between. It'll just make one long line of stuff. So you just kind of need one set of dollar signs per line around whatever math stuff you have together. Okay, I know that's kind of complicated and technical, but just give yourself some time to practice. We'll do more of that in Calc 2. It's a good way to type mathematics on the computer.